Welcome to Robotics, where we discuss recent research advancements in the field of neuroscience and robotics. Welcome back to Robotics. So get this, there's a new robotics paper. It just came out at CorOL 2024. You know the conference on robot learning?
Oh, yeah.
Well, the paper's called Dreamitate, Real-World Visuomotor Policy Learning via Video Generation.
Okay.
And it's from this, powerhouse research team, people from Columbia University,
Oh.
the Toyota Research Institute, and Stanford University.
That's impressive what they come up with.
Well, imagine trying to teach a robot to do something super delicate, scooping beans into a bowl or turning a nog just right.
Right.
That's always been a total nightmare to program, hasn't it?
Yeah, it's a ton of data. And even then, robots, they always seem to get thrown off by the smallest things out in the real world, you know?
Exactly. But these researchers, they had a completely different idea.
Oh.
What if, instead of programming each and every move, we just let the robot learn by watching, videos of humans doing the task?
Hold on, watching videos, how would that even work? How would the robot know what to do?
Okay, so picture this. They train an AI on tons of videos of people using tools.
Yeah.
But there's a twist. The tools, they were specially designed to be super easy to track in 3D.
Oh, okay.
So you're capturing more than just how the person moves, right? You're also getting the whole movement of the tool through space.
I see.
Exactly. So now, say the robot is in a new situation.
Yeah.
Like a different bowl or a totally new type of object. The AI can actually generate a video, and it predicts how a human would use the tool in that specific scenario.
Whoa, so the AI is kind of like dreaming up the solution. Is that where they got the name Dreamitate?
You got it.
Yeah.
And here's the best part. The robot doesn't try to, perfectly copy the whole human body or anything. It just looks at that tool and how it's moving in the video the AI made.
That's smart. You avoid that whole problem of making a robot move like a person, which never really looks right anyway.
And because the AI has been trained on so many videos, think, millions of them, from all over the internet.
Wow.
It already knows a ton about how objects work in the real world.
That's incredible, the potential for it to, apply what it learned to a new situation.
Right. And let's not forget, this is way more practical.
Oh.
It's way easier to just record someone doing something than it is to program every little robot motion from scratch.
Talk about a shortcut.
Plus, because we have that video, the one the AI makes,
Yeah.
it's we can see what the robot is thinking. It makes the whole process way more transparent.
That's a good point.
So they have this really cool idea, but does it work? Did they actually test it out? In the real world?
They did. They put Dreamitate through a bunch of tests, 4 tasks. They got more and more complex. And let me tell you, the results are pretty wild.
Okay, all right, let's hear it. What kind of robotic challenges did they come up with?
Well, first, they had the robot rotate different objects, turning them to specific angles. They used some everyday things like boxes and a hammer. But they also used some custom-made shapes to really see what it could do.
Sounds strict.
So picture this. The robot has to pick up the object and rotate it a certain amount, say, turning it 45 degrees counterclockwise.
I see. A real test of dexterity. How did it do?
Dreamitate, it just nailed it. 92.5% success rate.
Wow.
That's way better than how the other method did, the one they were comparing it to. That one only got it right 55% of the time.
Wow, that's a huge difference. What was it about Dreamitate that made it so much better?
Well, they noticed that the other method, the baseline one, it often had trouble getting a good grip on the object, a stable grip. Sometimes it missed completely, or the object would slip out while it was turning it.
Yeah, that makes sense. Those are things that are really hard to program.
Yeah.
But we do them without even thinking about it.
Exactly. And that's where Dreamitate is so cool. Because it learned from watching all those humans. It can use that knowledge to figure out how to grab the object and how to make the turns smoothly.
Okay, so what about that scooping task? I'm guessing that one was even trickier since you're dealing with loose materials that are hard to predict.
Oh, for sure. This time, they had the robot scoop beans from one container to another. And there were obstacles in the way, too. So think about it. It had to figure out which container was which, how many beans to scoop, and then move the scooper just right.
That sounds like it needs really good motor control.
Uh-huh.
And an understanding of where things are in space. Not exactly what robots are known for, is it?
Right. And again, Dreamitate did way better, 85% success rate, compared to the baseline's 55%.
Okay, not bad.
The baseline method kept getting messed up by stuff in the scene, misjudging how high the bowl was, things like that.
It seems like that more traditional way of programming. It just makes more mistakes. You know?
It does.
Dreamitate, though, it seems to have a better idea of like the overall goal and how to do it no matter what the situation is.
Yeah, I think that's right.
Okay, so let's talk about that sweeping task. What was the setup for that one?
So for this one, they had the robot use a brush to sweep some particles to a specific spot on a table, while avoiding any obstacles, of course. This one really tested how well it could plan a path and deal with things changing around it, you know?
I bet there are a lot of different ways to do a task like that. Did the researchers like give specific instructions in those human demonstration videos?
Actually, they made sure to include different ways of doing it in the training data. Like sometimes there'd be a bunch of particles to sweep, and the person would sweep them in a different order each time. So the model had to like figure out the best way to do it based on what it saw.
Okay, so a good test of how flexible it is. So how did it do?
Dreamitate was amazing. 92.5% success rate. Again.
No way.
Yeah. The baseline, though, it really struggled. It only got it right 12.5% of the time.
Wow. That's a huge difference. Sounds like the baseline was totally in over its head.
It was. It kept bumping into things, missing the target. It just couldn't get it right. Dreamitate, though, it moved around perfectly and got those particles right where they needed to go.
Okay, so now for the last task, the push shape challenge. And probably the hardest one, right? If I remember, the robot has to move the object and get it into a specific position.
That's right. They trained it using these letter shapes. They were cut out of foam, and then they tested it on shapes it had never seen before, like numbers and polygons. It had to push these shapes to a certain spot on the table and get them facing exactly the right way.
I can see why that would be so hard. It's not just about moving it. It's about, like, knowing how pushing it will change the way it's facing.
You got it. And it also needs to understand how the object will, like, interact with the table and stuff. You know, like how much friction there is.
So did Dreamitate do well?
It did. They used something called mean intersection over union, or MIOU, to measure how well it did. Basically, it tells you how close the object ended up to the target, both the position and the orientation. Dreamitate got an MIOU of 0.731.
Okay.
Well, the baseline only got 0.5550.
That's a big difference in accuracy. So it's not just getting it to the right spot, it's getting it there facing the right way too.
Exactly. Dreamitate was way better at like making those little adjustments to get it perfectly matched up to the target.
It sounds like Dreamitate is really doing well in these tests. But what happens when there isn't that much data to learn from? Because in the real world, you can't always collect mountains of data, right?
That's a great point. And the researchers, they wondered about that too. So they decided to see what would happen if they reduced the amount of training data for both Dreamitate and the baseline.
Interesting. And what did they find? Did Dreamitate start making mistakes?
That's where it gets really interesting. As they gave it less data, the baseline method, it started doing a lot worse.
That makes sense.
But get this, Dreamitate, it kept doing really well, even with way less data.
Wow. That's pretty amazing. So it's not just effective, it's also way more efficient.
Right. Exactly. And the researchers, they think it's because of that video generation model, the one that's learned so much from all those internet videos. It's like it already has all this knowledge about how objects work. And it can use that knowledge, even when it doesn't have much specific data about the task.
So it's like it can, kind of, fill in the blanks, make educated guesses based on what it already knows.
That's a good way to put it. And that's one of the things that makes this approach so exciting. It's not just about copying what humans do. It's about using all this knowledge to help robots learn and adapt.
And some of this research is opening up a whole new way to teach robots.
It really is. And while there are still some things to work on, like it needs tools that are easy to track visually, and these video models, they need a lot of computing power.
Yeah, those are important things to think about.
The potential here is huge. We're just starting to see what might be possible with this kind of approach.
I'm curious, what do you think are the biggest implications of this research? What's the big takeaway here?
It's amazing, really. This approach is a lot like how humans learn, you know? We learn by watching other people, by figuring out how things work, like what causes what.
Yeah. It's like giving robots that intuition.
Yeah.
That gut feeling about how to do something.
That's it. Instead of breaking down every little step, we're letting them learn more naturally. They can like pick up the details and figure out how to change things up depending on the situation.
It makes you think about all those industries that still rely on people doing things by hand, right? Like manufacturing or logistics. If we could train robots just by showing them what to do,
Exactly.
that could change everything.
It really could. Imagine how much easier it would be to work with robots. We wouldn't have to program every tiny detail. We could just show them, and they'd figure it out.
Yeah, it'd be more like working with them, like their partners.
I think you're right. It opens up a whole new world of possibilities for how robots can help us solve problems, make our lives better.
It's pretty mind-blowing to think about robots that can learn from us, adapt to new things, and really work with us like teammates.
It is exciting. Of course, there's still more to learn. We need to see how this works with even more types of tasks and how to make these models more efficient so they don't need as much computing power.
Right.
And of course, we need to make sure they're safe in the real world.
Yeah, that's important.
But there's no question the potential is huge. This Dreamitate research, it shows us a future where robots aren't just tools. They're collaborators, learning and growing right alongside us.
And that's a future I'm excited to see.
Me too.
It's been great talking about this paper with you.
It really makes you think about, all those jobs that people still do by hand, like in factories or delivering packages, stuff like that.
Yeah.
Imagine if we could train robots to do those jobs just by having them watch us do it.
That would be incredible.
It could totally change how we think about work and how we use robots in all kinds of places. And think about it, if we didn't have to program every single detail, it would be so much easier for people and robots to work together.
Yeah, like you were saying before, more like partners.
Exactly. We could just show them what needs to be done and let them figure out the rest.
That opens up so many possibilities, doesn't it?
It really does. It's amazing to think about. Robots that can learn from us, adapt, and work alongside us.
Like real teammates.
Exactly.
It's pretty mind-blowing.
It is exciting. Of course, there's still a lot more research to do. Like, we need to figure out how to use this approach for even more types of tasks and how to make these models work better, use less computing power.
Yeah, that makes sense.
And of course, we need to make sure they're safe to use in the real world.
That's really important.
But the potential is huge. There's no doubt about that.
For sure.
This Dreamitate research, it really gives us a glimpse into the future, a future where robots aren't just tools. They're collaborators. They can learn and grow with us.
That's a future I want to be a part of.
Me too.
Well, this has been fascinating. Thanks for breaking down this paper with me.
No problem.
And to everyone listening, thank you for tuning in to Robotics. Don't forget to subscribe and turn on notifications. Stay updated on all the coolest research in robotics.